Um, okay. Assalamualaikum warahmatullahi wabarakatuh. Good morning, sir and friends. Today, my group want to present our final project about image classification with sample dog and cat. Let me introduce myself. My name is Vianatha, and then this is my friends Yusuf, Hamzah, and Reno Adhabias. First one, the abstract. Many problems in computer decrease their accuracy before a decade. However, with the advent of new learning techniques, the accuracy of this problem has increased drastically. One of the main problems is image classification, which is defined as predicting image class. Dog and cat image classification is an example of cat and dog image classification. This paper aims to incorporate advanced technique for subject detection with the aim of achieving high accuracy. A convolutional neural network has been constructed for the image classification task. Okay, next introduction. The dogs versus cats image classification has been around for a long time now. The dogs versus cat competition from Kaggle is trying to solve the CAPTCHA challenge, which relies on the problem of distinguishing image of dogs and cats. It is easy for humans, but evidence suggests that cats and dogs are particularly difficult to tell apart automatically. Okay, next okay. Convolutional neural network. The name convolutional neural network indicates that the network employs a mathematical or convolutional operation. Convolutional is a specialized kind of linear operation. Convolutional networks are simply neural networks that use convolutional in place of general matrix multiplication in at least one of their layers. Okay. A convolutional neural network consists of an input and an output layer. Okay, this one is the figure that basic CNN architecture we use. The dataset and data augmentation. The dataset in Keras is divided into folders and each class. The dataset is divided into training and testing set. The training set and the test set composed of two folders, one for cat image and another one for dog images. There are 4,000 images of each cat and dog for training and 1,000 image of each cat and dog for testing. The image of varying shape and sizes. But in order to train a CNN, the image should be of the same size. Next, the model architecture is presenting by Reno.
So the model architecture. A classifier is a name given to the sequential model. The model first layer is a convolution 2D layer. Since the first layer of a model input shape of the image are going to be sorry. Balik ah. Anjrit. So, the fourth model architecture. A classifier is a name given to the sequential model. The model's first layer is a convolutional 2D layer. Since it's the first layer of the model, input shape of the image are going to be supplied to the model being mentioned. Next layer is a batch normalization layer. The one activation layer corresponding to the convolutional 2D layer. Further, there is another set of convolutional 2D batch normalization and activation layer with different number and kernels in convolutional layers. After that, a max pooling layer is there and then drop out the layer there. Now, the fifth is modeling and compilation and training. During the model compilation, optimization algorithm, loss function, and the list of metrics are parameters which are to be taken care of. Adam is used as the optimization algorithm. Binary cross entropy is used as the loss function, and accuracy is the only metric used. Early stopping and model checkpointer callbacks are used to prevent overfitting and save the base state of the model. These are these callbacks are mentioned as a list during a training. Sequential models with generator is used to train the model. The model is trained for 100 epochs with early stopping model checkpointer callbacks. Itu kayaknya yang 100 epoch salah dah. Kita pakai 15 doang aja. Udah, biarin. Then, model evaluation. The model trains for 15 epochs, after which it stopped due to the presence of early stopping callback, which had patient parameter set to 5. The training accuracy keep on increasing, but the validation accuracy start to decrease, which might be due to overfitting. That was the reason early stopper checkpointer was used to prevent results obtained due to overfitting. Below is the table showing the end result of the training accuracy and train loss, test loss, and epoch.
Okay.
As you can see, we have 70% of accuracy right there. Yes, 70% of accuracy. The graph below shows the training accuracy testing accuracy versus number of epochs. It's evident from the graph that the train accuracy keep on increasing with the number of epoch, but the test accuracy become near constant after the second epoch. Now, the second is the graph below show the train loss and the test loss, versus the number of epoch. It's evident from the graph that train epoch loss keep decreasing with the number of epoch, but the test loss become near constant after the first epoch. The final accuracy was obtained initializing the model with the way of that were stored during training by the use of model checkpointer callbacks. Final accuracy of 77.10% was obtained on the testing data. In conclusion, in this paper, we built a deep convolutional neural network for image classification, cats and dogs specifically. Despite of using the only subset of image of an accuracy of 77.10%. Okay. We can go to the program. This is our program. My partner Yusuf will explain it to us.
Okay. First, if we want to try this project, first we need to mounting the Google Drive to Google Collapse, and then we need to change the directory by find the directory from our Google Drive, and then if you want to look the list file in the directory, we can check it by this code, and then we can show the dataset in the folder train by this code, import OS, catch directory, and then this code will show us the dataset in our folder. And then we use base CNN model. The CNN model we can code by this code. And then by the code we can found 8,000 images belonging to the class. And then after that we make literation data, and then we get
800.
800 800 list data. And then this data will plotting by the model in this code. We'll process that, and then this is the graph we get from the data. This is for the training and validation accuracy, and then this is the training and validation loss. But since both accuracy and loss increase at the same time, the possibility of filter extraction is biased. So if we want to get a more accurate data, we can use cross-validation before this to make sure the data more accurate. And then this is the code for saving the model. We save as the tubes.h5, and then import the model to the what is that? To the Google Drive.
File.
Yeah, this is the code, and then this is the predicting image. The example, if I choose this, first I choose this image. So the process predicting will be doing, and then this is the result. It's a cat, but because this is overfitting, sometimes the model created is to focus on certain training dataset. So if cannot make the prediction correctly, if other similar data set are given, the overfitting will usually capture noise data that will otherwise be ignored. Yeah, maybe something like this. I try to find the miss data. Maybe this. Nah, you can see this program say there is a dog, but we know this is a cat. This can happen because that overfitting. And then this is for the example is a cat.
I think that's it for the demonstration of the program.
Okay, thank you for Yusuf and Reno for your presentation. Thank you for sir and friends for listening to our presentation. Thank you, and I want to apologize about our mistaken. Good afternoon all. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.